Welcome to the class of engineering mechanics. In the last class, I discussed about the center of gravity by geometrical consideration. Today, we will discuss about center of gravity by moments as well as center of gravity of a symmetrical section. Okay. So, first of all, take center of gravity by moments. Okay, this is a body. Its mass is m. Let's consider its mass is m. Actually, the center of gravity of a body may also be found as moments. Okay, in the last class we find out the moments. In the last class we find out the center of gravity by geometrical consideration. Okay, like in case of triangle, in case of rectangle. But in by moments also you can find out the center of gravity. So this is a body, center of gravity of a this mass is m. Okay, and whose center of gravity is required to be find out. This body center of gravity is required to be find out. This is you can see this is a irregular shape. This neither can be a elliptical shape. This is not a circle. Okay, so how we can find out its center of gravity? By geometrical consideration we can't solve this. Let's divide the body into small masses. This is a mass. This is a part. This is a part. This is part. Okay, and this is your axis, this is y axis, and this is x axis, and this is y and x axis. Okay, and this is your center. Now take this distance as x1, this distance as x2, this one is x3. Okay, and this is goes on. So we divide the body into small masses whose center of gravity are known as at first let take this is the for this divide portion, this portion mass is m1, this portion mass is m2, and this portion mass is m3, and this portion m4, m5, m6 goes on. And the masses of the particle, as this one is coordinate, what is x1 and this is y1, this is x2 and this is y2, this is x3 and this is y3, right? So let x and y be the coordinates of the center of gravity of the body. From the principal moments we know what is we can say that m into x, this is the whole body mass, equal to m1x1 plus m2x2 plus m3x3 plus, and goes on to the nth time, right? So from here we can say x is equal to summation of mx divided by m. This portion is comes down, and similarly we can say for y bar also this is summation of my divided by m, where caps m is equal to m1 plus m2 plus m3 plus goes on mn. Okay, so these are the method. This is the method of moments. Method by moments we can find out the center of gravity of any mass. Okay, now there is this term that is axis of reference. We have to know what is axis of reference. The center of gravity of a body is always calculated with reference to some assumed axis, right? From that, this is x-axis, this is y-axis. For calculation of the x, we assume the axis of reference as x, and for calculation of the y, we assume the axis of reference is y. Okay, so is known as axis of reference. So the axis of reference of plane figures is generally taken at the lowest line of the figure for calculating y bar, and the left of the line figure the calculator of x bar. Okay. Now move on to some interesting numerical problem. Like, we have to find out the centroid or center of gravity of random figure, like T section, like channel section, H section, angle section. Okay, so let's start from T section. So I am taking a T section. This is a T section. I am going to give the dimension. This is 100 millimeter, and the wave portion is take how much? 30 millimeters. Okay, and this flange portion also has a breadth of 30 millimeters, and take the overall depth of the T section is 150 millimeter. First of all, just learn the technical terms in this T section. This is the flange portion. So this is the length of the flange. This is the depth of the flange. That portion is called wave of T section. This is the depth of the wave. This portion is the depth of the wave. And this portion is width of the wave, and this is also called width of the flange. Okay, don't take length of the flange, always say this is the breadth of the flange, and this is the breadth of the wave, and this is depth of wave, and this is depth of flange. Clear? Now this is a T section. First of all, divide it into two parts. How I am dividing? This is 1, this is 2. Okay, I have to find out the center of gravity of the whole T section. First of all, I divided it into two parts. This is a rectangular portion, and this is a rectangular portion. Okay, so first take this rectangle. A, B, C, D. Okay, and this is A, B, C, D, E, F, G, H. So first take from ABCD rectangle. From ABCD rectangle we can say what will be our area. The area of this rectangle will be A1 is equal to 30 into 100, because this is the length and this is the breadth. So this is right. And what will be the y1? Y1 will be 150 minus, this is 30 by 2. Now we will say, sir, what is y1? Okay, y1 is nothing but from this figure. This figure has neutral axis in this point. Okay, So this is the axis of reference I am taking. Okay, so I have to find out the neutral axis distance of that figure to the axis of reference distance. That means we have to find out this one as y1. So this one is 150 and this one is 30 divided by 2. So y1 is equal to 135 millimeters. Done. Now in case of rectangle EFGH, what we find out from EFGH? From EFGH, our area is how much? This one is 150, this one is 30, so this one is 120. So 120 into 30. This is 3600 millimeter square. And what will be your y2? Y2 will be how much? This portion. Okay, so this is your y2. So y2 will be nothing but, this was how much? 120. 120 divided by 2. 60 millimeter. Now we know that the distance of the center of gravity of the section and bottom of the flange FH, GH will be what is equal to A1Y1 plus A2Y2 divided by A1 plus A2. So A1Y1 is how much? 3000 into 135 plus A2 is how much? 3600 and Y2 is 60 and divided by A1 plus A2. A1 is 3000 plus A2 is 3600. So by calculating I am getting okay 94.1 millimeters. Okay, by calculating the value is comes 94.1 millimeter. So the distance of the centroid from this baseline will be 94.1 millimeter. Okay, so I am taking, this is 120 total, so this can be your G value. Okay, 94.1 millimeter. This is G. G means, oh sorry, G dash. Actually this is G. Okay. So this is how done you can done the calculation of center of gravity for T section. For same, this is channel section is also there, I section is also there. In the next class I will teach you how channel section and I section can be determined. Okay, so thank you, that's all for today now.